Bearcats, it's Unit 11, Chapter Review, and we're going to start with your review page, and then we'll end with the book pages. All right, for 1A, we're asked to evaluate in radians, arc, cosine, the square root of 3 over 2. All right, here's what we're doing right now. Remember, arc is an inverse, and that just gives us a restriction of our domain. So cosine, arc inverse cosine is going to be restricted to the first through the second quadrant, which means we're going to be restricted from 0 radians to pi radians. So somewhere in that rotation will be our angle. The next thing you're going to do is you're going to ask yourself where the square root of 3 over 2. Where is cosine the square root of 3 over 2? There's several ways to go about this, but I think the best thing to do is to know your chart. We've talked about that all year. I'm going to write it down one time and then I'm just going to reference it. We've had this same chart all year. So we know that at 60 degrees, which is pi over 3, we have 45 degrees, which is pi over 4, and we have 30-degree angles, which are pi over 6. And we know at 30 degrees, or pi over 6, that's our radian measure, that our values for cosine, sine, and tan are as follows. For cosine, we have the square root of 3 over 2. Ah, there we go. And then sine would be 1/2, and this would be the square root of 3 over 3. Jump up to the 60-degree angle because they're reciprocals of the 30-degree angle. So we're going to switch, and we're going to have cosine as 1/2, and sine is the square root of 3 over 2, and tan is just the square root of 3. And then, of course, the 45s are the easy. Those are the legs are the same, square root of 2 over 2, square root of 2 over 2, and 1. All right, so from our chart. So the first thing we're going to do is go inverse sine. This is our restriction. The next thing we're going to do is cosine. Since this is a positive value, cosine would be positive in this quadrant because all surfers. Cosine or x would be negative in the second. So because we're restricted, we can't be in the third or the fourth, and it's positive, we'll be in the first quadrant. So all we have to do is look for our reference angle. Where is cosine the square root of 3 over 2? And that would be right here, and that's at pi over 6. So pi over 6 is our answer. All right, let's look at 1B. 1B, we have arc tan, or inverse tan, of negative square roots of 3 over 3. All right, first thing we do is it's an inverse tan function. Inverse tan is restricted to the first quadrant or the fourth quadrant, but moving in a negative direction. The next thing we're going to look at, it's negative. Well, nothing can be negative in the first quadrant, and we're restricted, cannot be in the second or third, so our restriction would force our negative to be in the fourth quadrant. And we're rotating in a negative direction. The next thing we do is go to our chart and go, where is tangent the square root of 3 over 3? That would be right here, except that it is negative, so it's in this quadrant. We're moving in a negative direction, and that would be at pi over 6, but because it's in a negative direction, it would be negative pi over 6. All right, let's keep going. 1C. 1C gives us sine, inverse sine, 0. All right, this is back to our four corners of our circle. We know this is 1, 0, 0, 1, negative 1, 0, 0, negative 1. And, of course, our tan would be 0, undefined, 0, and undefined. And those are the same thing. It's our cosine, sine, and tan values. I think you know all of that. If you don't, that seems really foreign to you, then you're a little bit behind where you need to be. All right, remember inverse sine, okay, because the inverse symbol, inverse sine, is restricted to the first or the fourth quadrant moving in a negative direction. We want to know where sine is 0, so in that area, the only place sine can be 0 would be right here, and that's at 0 radians, so 0 would be our answer. All right, how about 1D? We have inverse cosine, negative square roots of 3 over 2. All right, this is where it gets a little tricky, so you need to pay attention to this part. So again, we're inverse cosine, so we're restricted for cosine in these two quadrants, all in a positive direction. So if it's a cosine value, inverse is restricted, but it's all moving in a positive direction. So your radians would have to be a positive value. Now we're looking for that the output of that is negative. That would be a negative x, so that would be in this quadrant because everything's positive in the first quadrant. It does not mean that the angle rotation is negative. It just means the value of that rotation would be negative. So now we're going back to our chart, and you can go look at yours again. I'll go back to mine. And where was cosine the square root of 3 over 2? That was at pi over 6. There's our chart. So at pi over 6, but that would be the reference angle, okay? The reference angle would be at pi over 6, but we're going back, and this is 6 pi over 6, and because we're in the second quadrant, not the first quadrant, it won't be pi over 6 over here. This is bigger than that. It would be 1 less than 6, so it would be 5 pi over 6. If you get that one, then you're in pretty good shape. Go Bearcats. All right, last one is 1e. For this section. We have tan, and then we have arc or inverse tan, negative 0.9. Tan, arc, tan, they basically cancel each other out. As long as your inverse tan is inside the parentheses, this is a composition, you do that first, then you should be in pretty good shape. So they're going to offset each other and become 1, and 1 times negative 0.9 is simply negative 0.9. So there you go. I could go through and show you that, but I think you got that. Anyway, so if you have the same trig function and your inverse is inside the parentheses, then you're going to cancel, and you're just going to end up with this value. I would love to spend a little more time on that, but not tonight. All right, let's go on to problem number 2. So this will be 2a to begin with. We're going to go ahead and continue our inverses, and this time we have cosecant of arc sine 4 over 5. Okay, I noticed 4 over 5 is not something off my chart. Don't recognize that. I'm probably going to be drawing a triangle, so I'm going to draw my grid. And the next thing I see is this is inverse sine. Do it in the parentheses first. Inverse sine. Sine will be restricted to the first or the fourth quadrant, but moving in an opposite rotation. And since it's positive, we're going to be in the first quadrant, so I'm going to extend this, and we're going to make our triangle in the first quadrant. Sorry about that. All right, so sine, now you're looking at sine. We know sine to be opposite over hypotenuse. So from our first quadrant triangle, opposite would be 4, hypotenuse would be 5, and that would make our cosine or our x value 3. Once you do that, you've used all this information to set up your triangle, then you're done. It restricted it. If there was no restriction, then sine could also be positive in the second quadrant, and we'd have 2 triangles, but we don't. So we're going to leave it here. This is our triangle. You're done with this, and now you're simply looking to find what cosecant is. So cosecant theta would equal. Cosecant is the reciprocal of sine, so it's going to be hypotenuse over opposite, which you would have, if you had known that, you probably could have just done that from that. So it's going to be 5 over 4. All right, 2b, or not 2b, sorry. All right, here we go. Cotan, cosine, inverse, or inverse cosine, 5/13. All right, again, we're going to draw a triangle. And in our triangle, we're going to have inverse cosine. We're restricted to the first and the second quadrant. Again, it is positive, so we'll be in the first quadrant. We're going to draw a triangle in the first quadrant. Cosine is adjacent over hypotenuse, so adjacent would be 5, hypotenuse would be 13. Pythagorean theorem makes my missing side 12. Now I want cotan. So I used all of this to get my triangle. I'm done with that. Now I want cotan. Remember, cotan is going to be adjacent over opposite. So adjacent would be 5, opposite would be 12, and I am Dunsky. All right, let's move on. Okay, now we're on to graphing. Remember, for our reciprocal graphs, our tan and the reciprocal. So tan, cotan, and then cosecant and secant. All you need to know is how to graph a parent graph, and then you need to know the asymptotes and the domain and the range. Remember, I said that the domain and the range is going to be a multiple choice selection. You'll actually physically graph it, and then it'll be a multiple choice selection, whether to pick out which is the domain, the range, and the period. So please don't think there's 3 parts to those questions when you get to your test. All right, so tangent. A couple things that we know. We know that tan, look at this. I'm going to go ahead and pi over 2, 3 pi over, pi, 3 pi over 2, 2 pi, negative pi over 2. All right, so look at this. For tangent is undefined at pi over 2. So we're going to draw an undefined line. If I rotated this way, we just came out of inverses, remember, and tan was restricted. We're not going to restrict, but we are going to look at that. If we rotated backward, it would be at negative pi over 2. It would also be a restriction. And you want your graph to go through the origin. So at 0, your tan value is 0. Now, what's not on here is at 45 degrees, you should remember from your chart, go back and look at it, at 45 degrees, tan is 1. So this is 1, this is negative 1. At 45 degrees, which is pi over 4, in between 0 and pi over 2, tan is 1. If we go the opposite direction, at 45, tan would be negative 1. And your tan graph looks like this. All right, just so you know, the period for a tan graph is pi. So from negative pi over 2 to positive pi over 2, that total distance is pi. We have asymptotes. You're going to go from the origin to the right. The first asymptote to the right is pi over 2 plus each period. So plus increments of pi. That's important you understand that. The domain would be all real values except pi over 2 and increments of pi. So it could not be. So x cannot equal. And then our range is going to go, notice it goes up with an arrow to infinity and negative infinity, so negative to positive infinity. All right, let's look at cotan. Remember, anytime something is undefined, the reciprocal is 0. Anything is 0, the reciprocal is undefined. So I'm going to add my cotan values on here. Since tan is 0, cotan would be undefined. Since tan is undefined, cotan would be 0. Since tan is 0, cotan would be undefined. And since tan is undefined, cotan would be 0. So let's take a look at that. So at 0 radians, cotan is now undefined. So we have an asymptote at the origin. At pi over 2, we're at 0. And at pi, we're back to undefined again. So for cotan, the period is going to be a pi, and it runs from 0 to pi. 0 to pi. Because we want to make sure that we get our first 0. All right, between 0 and pi over 2, which is pi over 4, cotan would be the reciprocal of 1 or 1. And between pi over 2 and pi, which would be 3 pi over 4 right here, I'll make this 1, and this down here is negative 1. It would be negative 1. And our cotan graph looks like this. A lot like the sine graph, but different asymptotes. So the asymptotes would be, since 0 is an asymptote, then you don't need to say anything. You could say 0 plus if it helps you, 0 plus. And since it's a distance of pi for each period, so 0 plus increments of pi. The domain would be all real values except x could not equal increments of pi. And you could say 0 increments of pi. And the range, again, is negative to positive infinity. All right, let's go on and do the cosecant and secant real quick. All right, let's look at cosecant and secant here. All right, cosecant is reciprocals with sine. So we're going to build our sine graph. This is 1 and this is negative 1. And if you remember from our basic sine graph, sine starts at the axis. From our little unit circle, 1, 0 is our ordered pair, and our sine value is 0. So 0, 0. Then at pi over 2 would be the top of the amplitude, or at 1. Pi, it would be back to 0. 3 pi over 2 to the bottom of the amplitude, or negative 1, and back to 0. So our sine graph looks, I'm going to dot it in, looks a lot like this. Cosecant are reciprocals. So where they cross the axis, we're going to have asymptotes. And we're going to go to the top of the amplitude, and it's going to be like this curve flipped itself outward and moves upward. And this curve flipped itself outward, and it moves downward like that. And that is our cosecant graph. The dotted line is the sine graph. The solid line is the cosecant graph. For cosecant, our period is 2 pi. Our asymptotes, again, since we start at 0, it's just pi in increments of pi. So it would be n pi. Our domain would be all real numbers, except x cannot equal increments of pi. And our range, okay, our range is a little different. Our range moves from negative infinity up to negative 1, and then from positive 1 to positive infinity. So negative infinity to negative 1, excuse me, or from 1 to positive infinity. All right, let's look at secant. Secant is buddies with cosine. So let's sketch our cosine graph first, and we're at 1 and we're at negative 1. We can build our highways if that still helps you. That will help you with your transformation ones, probably. All right, remember cosine at the origin starts at 1. So it starts at the top of the amplitude. Then at pi over 2 it goes to 0, pi, bottom of the amplitude, 3 pi over 2, 0, and 2 pi back to 1. All right, again, where it crosses the axis is our asymptotes. And our secant graph moves toward the asymptote. So here it's going to move up toward the asymptote. Here it's going to move back down toward the asymptotes. And here it's going to move toward the asymptotes. All right, and that's what our cosecant graph looks like. What our cosecant graph looks like. Our secant graph looks like. All right, the next thing we're going to do is our period. Our period again is 2 pi. Our asymptotes are at pi over 2. And then a distance of pi. So from pi over 2 to 3 pi over 2 is a distance of pi, so plus increments of pi. Our domain would be all real values except x could not equal pi over 2 and increments of pi. Oops. In pi. And our range, like before, we go from negative infinity up to negative 1 and from positive to 1 to positive infinity. So from negative infinity to negative 1 or from 1 to positive infinity. All right, go Bearcats. There's our graphing of our basic cotan, cosecant, and secant graphs. The next thing we want to do are the transformations on your worksheet. All right, the first graph we're going to graph is this one. We got two things going on. We have our basic sine graph, but we have an amplitude change, which is a vertical stretch, just imagine that, and we have a reflection. So let's go ahead and get started building our graph. Our amplitude means our graph is going to get stretched. Our original amplitude was 1, and now our amplitude is going to be a distance of 3. Our axis has stayed the same. So from the axis, we'll count up 1, 2, 3. We'll count down from the axis, 1, 2, 3. And that'll be our new amplitude. And that's where I'm going to put in my little highway. All right, the next thing we're going to do is we have a reflection, but remember, and I'm going to go and just put in our graph, pi over 2, pi, 3 pi over 2, 2 pi. Remember, sine graphs start at the axis, so we would start right here. Because there's a reflection, instead of going up first, we're going to have to go down first. Then it's just a pattern to the axis, top of the amplitude, back to the axis. And this sine graph will look like that. All right, moving on. 3b. We've got y equals negative 2 cosine x. All right, again, our amplitude has changed to 2, and we have a reflection. So again, we're going to draw our graph. pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2. All right, our amplitude is now 2, so count up 1, 2, and down 1, 2. And that's our little highway. Oops. And now remember, our cosine graph starts at the top of the amplitude. Oh, hold on. There's a reflection. So we won't start at the top. We'll go to the bottom of the amplitude. That would be reflecting over the x-axis. Then back to the axis, top of the amplitude, back to the axis, bottom of the amplitude. So our cosine graph, in this case, would look something like this. All right, go Bearcats. 3C. Y equals cosine x minus pi. All right, this time no amplitude change, no reflection, so our amplitude will remain 1. But this time we have a shift, a left and right shift. Remember, when it has to do with x values, it's opposite of what you think. So this says minus pi. We're going to go to the right a distance of pi. So we're going to move to the right, shift, right, pi. All right, so our cosine graph, let's see what happens. So this is pi over 2, pi, 3 pi over 2, 2 pi. And because we're going to go to the right, I'm going to add some. So this will be 5 pi over 2, 3 pi. All right, our amplitude is 1. I'm just going to label this 1, just make it easier to graph. And I'm going to say that's my highway. Now, typically, my cosine graph would start at the top of the amplitude. But what happens? We're going to shift everything to the right pi. So it's going to start at the top of the amplitude above pi. And then we're going to go to the axis, bottom of the amplitude, the axis, and back to the top of the amplitude. All right. And on our test, it may say 2 full periods. I want 1 full period, just 1. So our cosine graph will look like that. Okie dokie. You can pause if you want. I'm moving on. 3D. So we have y equals sine x plus pi. Same kind of thing here, except this time we're going to shift not positive direction, but a negative direction pi. Again, we're going to draw our graph. We have pi over 2, pi, 3 pi over 2, 2 pi. And we have negative pi over 2 and negative pi. All right, so everything's going to shift to the left 1. Again, no amplitude change, so this is 1, and I'll count. This is negative 1, so there's our little highway. And we're shifting, the sine graphs always start at the axis, but we're shifting left pi, so that would move us all the way over here to negative pi. From there, you're going to use the same pattern you have. Top of the amplitude, axis, bottom of the amplitude, back to the axis. That's 1 period of your sine graph. And there you go. Bearcats. All right. How about E? We have y equals 3 plus sine 2x. All right. I kind of like to rewrite this equation. I'm going to write it as y equals sine 2x, and since that's a positive 3, I'm going to say plus 3. I don't know why they put the shift in the front. I would put it at the end. There is no amplitude or period change. I'm sorry, amplitude or reflection. We do have a period change, and we do have a movement, a shift up. Let's do this first. This is going to shift up 3. So the whole graph will shift up 3. And now we have a period change. The original period for sine is 2 pi. We are going to now divide by this number. This is called our b value, and we're dividing by b. So I'm dividing by 2. So I really have 2 pi, and if I want to multiply by the reciprocal, I'm multiplying by 1/2. The 2's would cancel out, and my new period is now just pi. All right, so that's my period. So in other words, that whole sine curve has to happen between 0 and pi, and my whole graph is shifted upward. Is shifted upward 3. So here we go. So I'm first going to take my axis, and I'm going to change colors to help us out a little bit. Okay, so our graph has to curve between 0 and pi. Now, because we've done that, I'm going to think of this mark out here. I'm going to change my axis a little bit. I'm going to come out here, and I know we have pi over 2, and I know we have pi. And everything has to happen between there. I need 2 more points. So I need one between 0 and pi, which would be pi over 4, and one between pi over 2 and pi, which would be 3 pi over 4. So it's halfway in between. I need those, actually, if you count the axis starting, you have 1, 2, 3, 4, 5 points to graph. Our graph is shifted up 3. Oh yes, I was going to change colors. Hold on. I think we'll just highlight our new axis. Okay, so we're going to shift our entire axis up 3. So 1, 2, 3. This is now going to be our new axis. I'm going to highlight that just to make sure that we really, really know that that's our axis. So this is my new axis. All right, so that's where my axis. My amplitude, there is no change, so it's just 1. So from my new axis, I'm going to move up 1, and that would be my highway. I'm going to move down 1, and that would be my highway. And I already have my new labels here. So I've shifted everything up, I've changed the period, I've written my highway. It's a sine graph. Sine starts at the axis. And you've got to start at the new axis. And then at pi over 4, it would go to the top of the amplitude. At pi over 2, it would go back to the axis. At 3 pi over 4, it would go to the bottom of the amplitude. And at pi, it would go back to the axis. And now this is what your graph would look like. All right, you may need to pause and think about that. The big thing is the period is 2 pi divided by b. And b is that multiplier in front of the x. All right, let's move on to F, and then we're going to go on to the book stuff. All right, 3F. We have y equals 2 plus cosine 2x. Again, I would move that to the end, and I would have cosine 2x plus 2. No amplitude change, no reflection, so the amplitude would stay 1. The graph does shift up 2, and we have a period change again, and we already kind of know what that is, but we'll just say 2 pi divided by 2 is the same as times 1/2. Cross out the 2's, and our period is pi. All right, so let's go ahead and get our graph. So we have pi, oops, let me do it right here, pi over 2 and pi. And since that's as far as we're going to get our graph, then we're going to go in the middle. Halfway in between would be pi over 4, and halfway in between would be 3 pi over 4. You need to label really well. All right, our whole axis is going to shift up 2. 1, 2. So I'm going to draw in my new axis, and I'm going to highlight that. So here's the new axis. That's going to help us identify. Otherwise, it's really easy to overlook and go back to your old axis. All right. Since it's cosine, it's going to start at the top of the amplitude. Uh-oh, we need our highway. So from our new axis, our amplitude is 1, so we just have a little highway up here. And 1 below that axis would hit my highway right here. That kind of gives you your space to mark in. All right, cosine starts at the top of the amplitude. So at 0, cosine would start at the top of the amplitude. And then we have these new marks, so we can have 1, 2, 3, 4, 5 marks. So at pi over 4, it would go to the axis. At pi over 2, the bottom of the amplitude. Pi over 3 pi over 4 back to the axis, and pi back to the amplitude. And so your cosine graph would look like this. All right, go Bearcats. All right, I'm not working all of these out of the book. You've worked them, you can check them. You also have a hard copy, but I will work one of each type. So I'll work number 2. This is from page 359. And this is number 2. All right, for number 2, they ask you to use a triangle that's given to you, and the triangle that they give you looks like this. And it's A, B, C. This is your right angle. And, of course, they have it labeled. And for number 2, they give you that angle B is 54 degrees. So this is given. And they give you side C is 15. And they want you to find the missing angles and the missing sides. Well, to find A, it's a right triangle, and all triangles add up to 180, and you have 2 of the sides. So to find angle A, you would take 180, you would subtract 54, and you would subtract 90. And when you do, you have 36 degrees. So angle A would be 36 degrees. All right, for sides. You can go from either angle. I'm going to go from the one I was given in case I ever make a mistake on one I find. I don't, follow my mistake all the way through. So I'm going to start with 54. 15 is the hypotenuse. That was the side I was given. And let's say I want to find side B. Let's say I want to find little b. So hypotenuse over little b, or little b over hypotenuse. Let's do that one. So little b would be opposite 54, so opposite over hypotenuse would be sine. So I would say